All right, measures of central tendency, because we're in the Central California or Central of America. I don't know, Central. Moving on, let's go. Okay, so first, what is a measure of central tendency? Well, those are those three things you've probably heard before: the mean, median, and mode. Those are the three things that are your measures of central tendencies. So the measure of central tendencies would be the mean. The mean is the average. That's what a lot of us remember. And then the sum of the data, so the average is all the data added together, so the sum, and divided by however many are in the data set. So a data set would be like, if a whole class had, there's 20 people in the class, I have 20 different test scores, and I add all the test scores together, divide them by 20, that's my that's my average. The median is the middle number. So if I lined them all up from greatest to least, and then the middle one is the median, and the mode is the number that occurs the most often. So if I said that, we had 17 people get a 90% on the test, and there were 20 people, the most often used one would be the mode. Let's look at this in a better picture. Okay, so a mean, this would be all the numbers divided together. So if I had, or added together, so I had 3, add them all together. And then there's a total of 6, 1, 2, 3, 4, 5, 6. Divide them by 6. 30 divided by 6 is 5, so the mean is going to be 5. So the order of numbers is the median. So I would actually take them all in order. So I'd go from least to greatest. So I'd go 1 goes there, 3, 3, and I just keep writing them down, 6, 8, and 9. And I circle the middle number. Well, in this case, they had, and I'm not sure if this is how our homework's going to be. We'll probably run into this in a sec. Then they averaged these two. So they added them together, came up to 9. The median's 4.5. Sometimes our homework might say the median is 3 and 4, or 3 and 6. But we'll see how that comes out. So the most common number, if there's something that happens more often, it comes out to 3. We'll see a prettier way of doing that here in a sec. All right, so the revenue for the 10 highest grossing movies as of June 2000 are given in this table. Find the mean, median, and mode of those revenues. So millions, here's the top 10 movies in millions. Wow, June of 2000, that's a long time ago. Star Wars made over $1 billion. Just going from there. Anyways, so the mean is going to be the sum of all the revenues divided by however many movies there are. Well, they told us there's 10 movies, so there's the number of movies. So I'd add all the numbers, 601 plus 461 plus 361, and you'd probably punch all that in your calculator. And I'd be okay if you wrote like this with these triple dots here to the last one. If you want to write it down that way, that would count as showing your work, divided by however many movies there are. If you could count them up, or you could look up there. Once I add them all together, it comes out to 3798 divided by 10 comes out to this. So my answer would be that ever many, $379.8 million. So find the median in orders from least to greatest. So if I lined them all up from least to greatest, which this one they were kind of lucky, they're already in least to greatest like this. So lucky you, if that was your case. So we'd line them up from least to greatest, and you can then find the middle number. So it'd be like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay, so this is going to answer our question, what happens if there's an even number to find the median? The book wants us to add them together and divide by 2. So if there's an even number of items, find the mean, or the of the two middle numbers. So the median revenue is $343.5 million. So there is no mode because no number happens more than once. All right, find these, mean, median, and mode, go. All right, so I'm going to try to kill 2 birds with 1 stone in this one. So to find my mean, median, and mode. So I'm going to line them up by least to greatest first. So 62 is my first number. Is there anything in the 70s? I guess 75. 75, 78. Actually, these would all be adding because we're going to do that here in a second. 75, 78. Looks like then we go to the 80s, 83 plus 85 plus 85 plus 90. Oh, I'm running out of space. Plus 93 and plus 99. Not my best writing job, but that's okay. So I'd take those numbers and add them all together and divide them by 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. We'll add those in my calculator. I get 750 over 9. Divide those out. I get 83.3 for my mean. So my median, let's see, I go 1, 1, 2, 2, 3, 3, 4, 4, 5. So my median is that one, and my mode is the one that happens most often. There's only one double, so that's also 85. Let's see, 83.3, 85, 85. Sorry for my bad writing there. All right, Olympics, a line is drawn. A line plot here shows the number of gold medals earned by each country in the 1998 Winter Olympic Games in Nagano, Japan. Find the mean, median, and mode of the gold medals won. Okay, so this is a little more complicated, slightly different graph here. So there were this many countries that did 0, this many countries won 1, this many countries won 2, and so on. Okay, so we're going to add them together, and they actually kind of did this kind of multiplying thing. 0 was 9 people, 2 groups had 1, 4 groups had 1, 2, and so on and so forth. And they didn't do 7 and 8, and there's a total of 24 X's to get my bottom one number here. So that comes out to the average mean for countries. Each country won an average of 2.75 gold medals. And the zeros don't count because we cross them out because they didn't win. So when you added that one out, this would actually still be 0. All right, so there's 24 numbers. The median number for these would be an average of the 12th and 13th numbers. So the median is going to be 2 according to this one. So that's a little more complicated. You might actually have to write them all out or start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14th numbers. So that's why it was 2 and 2. And so the median of those two is 2. So the number that occurs most often is 0. So that would be 0 is the median, or is the mode. And on your marks, get set, and go. All right, so let's set this up here. So there is one person had 2 plus there's 2 groups that had 3 plus 4 groups that had 4, and I was 5. 5 groups got 5 plus 1, 2, 3, 4, 5, 6 groups that had 5 plus 3 groups got 6, and then looks like plus 2 that had 8, and then plus 1 times 10. And there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whoop. All right, well, I for once think the book is wrong. I've done this out 3 times. I've added multiplied them together in a graphing calculator. I've actually added them straight up, so 2 plus 6 plus, that would be 20 plus 30 plus 18 plus 2 times 8 is 16 plus 10. Those all come out to 102. And I've counted these up multiple times. There's 20 of them. Comes out to 5.1. That's what I think the right answer is. So the median, score is 5. So there's 20 things, so we need to find the 10th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those would be those two. So that's why 5 is the median. And the one that happens most often is 5. So there's your mode. All right, quiz scores for a math class. You keep rolling here. Are 8, 7, whatever, all those numbers. Identify the extreme values and describe how it affects the mean. So data values of 0 appears as an extreme, as in no one else got a 0. So we call that an extreme value. So we will calculate this mean with and without that extreme value. So the mean with the extremes, we'd add them all together, and the number of values is 13. So that makes it approximately 7.3. Well, if I take that 0 out, that will change this bottom number. So without the extreme, it'd be 12. So without that one random 0 value, it ups the grade as a class to 8.2 as the average. So there would be an increase or a decrease of 0.7 with that extreme. And you'll probably see a thing on your homework just like this. All right, do the same thing here. Identify the extreme and describe how it affects the mean. Go. All right, so I have 10 values. And when I add them all together, I get 75.5. So that'd give me an approximately 7.55 as an average. Now the extreme of this is this 4.1. So if I took 4.1 out of here and take 1 less here, that's going to give me 71.4 over 9. So let's do that, divide that by 9, and that gives me 7.93. So it raises it by approximately 0.4. That's what I would say. So it moves it by 4.1. Oh, sorry. The extreme, identify the extreme, 4.1. Describe, it moves it by 0.4. My goodness, everybody wants to email me right now. All right, table shows the monthly salaries of employees at 2 bookstores. Find the mean, median, mode of this. Based on the averages, which bookstore pays better? So we're comparing this side to this side. So I'd say we need to find the average of these two. So Bob's Books, we find the mean. Comes out to approximately that. And then the median would be this much. And the mode's going to be this. So let's remember those 3 numbers there. Punch that in on the second place. Mean comes out to that. Median comes out to that. Mode, there's none. There's nothing that happens multiple times. So now we need to average these, or talk about these together. So my mean salary is 1,900. My mode is 14 or 18. This side, they get paid a little bit less. So it looks like Bob's Reading Place doesn't pay as much, but the median salary is higher. So the salaries of Bob's Book is an extreme salary. So this one here really changes everything. The employees at the Reading Place are generally better paid by the median. So if we look at the median on this one, it's higher than on this one. This is where that extreme can make a big difference. All right, you try, go. All right, to save time, I've done some calculations early. Okay, so if I add all these together, they come out to 34. There's 6 of them. So when I punch those in, 34 divided by 6, that gives me 5.6. Usually 5.6 with a line over it. And my median here is going to be 4.5, because that's 9 divided by 2. And my median over here, or my average, 22 divided by 6, comes out to 3.6. And that comes out to, so those are the middle 2, and I circled the middle 2. I just counted over here. I was like, here's the lowest one. 1, next lowest 2, and then 3, 4, 5, 6. And I just circled the 3rd and the 4th one on both of these. That's how I came up with those numbers. And 2 and 4 comes out to 6 over 2 equals 3. So mode over here. So based on the averages, which gender exercises more? So these are the number of hours spent exercising each week. Looks like the men average about 2 more times a week, or 2 hours per week more, and the median's only 1.5, so it looks like the men exercise more. Let's see what the book says. Let's erase everything on the slide. So it seems men seems to exercise more. They wanted it simple. I like it. All right, Johnny's bowling average is this. Today she bowled these 3. What does this net score say about the 4th game to maintain her average? So how much does she need to score in the 4th one to maintain her average? All 3 of these are below. So first we read it, find the sum of the first 3 games, then write the equation needed for the 4th game. So first we find the sum of the first 3 games. So 141. So the mean of her first 3 scores is 141. So the sum of her first 3 scores goes here, and we multiply each side by 3. So this should be her average. So 143 is the number she needs to get in 3 games to have an average of 141. So find the 4th score. So find the score of the first 3 scores plus the 4th score and divide it by 4. So let's write that equation. So she needs to get, her average is 146. Her total number for the other 3 was this, and then we're going to add times plus x over 4. Now, I probably would have just added the first 3 scores together to get this number, because this whole step before was a little confusing. So I would just taken the first 3 scores that we had, add them together, put x over 4, and it needs to equal 146. So we multiply both sides by 4, divide by 423, and that means she needs to get at least a 161 in order to maintain her average of 146. So that's what this says here. Moving on. Or I guess I should say, see you in class.